Welcome to this video tutorial of inverse trig functions and what we're calling concept 5, which is dealing with an inverse trig function application where we don't have points that we know on the unit circle. So here's what we think. We don't know which point on the unit circle where the angle is to give us a tangent value of -1/3. So we're going to call this theta. And we're going to draw out a triangle, a right triangle that is. We don't know what theta is, but we're going to make this angle that value. Now, if that angle is theta, we would know that its tangent would have to be 1/3, which means the opposite is 1 and the adjacent is 3. We could use the Pythagorean theorem to find the hypotenuse. 1 plus 9 is 10. Hypotenuse is going to be the square root of 10. And now we want the sine of this angle. So the sine of this angle would be 1 over square root of 10. Make sure to rationalize, and we get radical 10 over 10. But the question is, will that be positive or negative? Well, the inverse tangent gives us outputs in quadrants 1 and quadrant 4. When it's negative, it will be down in quadrant 4. And in quadrant 4, sine is also negative, so this will be a negative radical 10 over 10. Next problem, similar deal. We don't know where the angle is on the unit circle that gives us an x-coordinate of -4/7. We know it's there, but we don't know what it is. So we're going to call that angle theta, and we're going to draw out our right triangle where we make it adapted to theta. Well, we know the cosine of that angle is going to have to be 4/7, so the adjacent side will be 4. The hypotenuse is 7. We can use Pythagorean theorem to figure out this other side. 49 minus 16, let's write that out to ensure that we don't make a mistake here. That's going to be 33, so this side will be the square root of 33. Now we want the tangent of that angle. Tangent would be the opposite side divided by the adjacent side. So it's radical 33 over 4. But is it positive or negative? Well, inverse cosine gives us outputs in quadrants 1 and 2. Since it's negative here, this theta is going to be from quadrant 2. And in quadrant 2, tangent is also negative. So this will be negative radical 33 all over 4. Now we also spice this up by making it variables. So we're going to look at 2 with variables, and in the disclaimer we made in class is we don't really care about positive or negative final answers in these scenarios. But we'll approach them the same way. We're going to call this theta. We're going to build our triangle with the angle that I'm picturing in the bottom left being theta. Cotangent is adjacent divided by opposite. So x divided by 1 would be x. Use our Pythagorean theorem. This will be square root of x squared plus 1. We want the cosecant now of this triangle, the angle in the bottom left. Cosecant is the reciprocal of sine, so it would be hypotenuse over opposite, which will just be square root of x squared plus 1. Since it's variables, we don't care about positive or negative. We really can't pinpoint which quadrant, so we're just going to leave it in that final format. Similar deal over here. We're going to call the inverse cosine of e to the x theta. We're going to make our triangle with a theta here. Cosine would be the adjacent over the hypotenuse. Use Pythagorean theorem. Now this one is neat. 1 squared. E to the x squared is really e to the 2x. And now the question is, what's the sine of theta going to be? Well, it's going to be the opposite, which is the square root of 1 minus e to the 2x divided by the hypotenuse, which is just 1. So there's our answer. And again, since we're using variables, we don't care about whether it's going to be positive or negative for the moment in this point. Right now, we just care about identifying that that is the expression for the sine of the inverse cosine of e to the x. So basically just identify your triangle, put the theta in the triangle, establish a couple sides, use the Pythagorean theorem, and then analyze to see what the final answer will be.